Okay, this is number 8. Number 8 is find the derivative using the definition of the derivative, and I want the derivative function. So I said 8, I lied, let's do number 9. So the original problem is square root of 2x minus 5. And I would like to know the derivative of this function. So the derivative we will find using the definition of the derivative, which is the limit as h approaches 0 of the original function, except instead of x, it's x plus h in the original, minus 5, minus the function all over h. And yes, this is one where you have to multiply by the conjugate. So I'm going to scoot over a little bit. I don't have room to write it, but the conjugate is just this numerator with a plus in the center. And we've done enough of these to know that everything's going to cancel out pretty nicely. All the roots are going to cancel, and you're going to be left with, I'm going to write this out as 2x plus 2h minus 5, minus this term without the radical. And I'll put the conjugate on the bottom because that's where it's still left over. It's 2x plus 2h minus 5 plus 2x minus 5. So after multiplying by the conjugate, which we've done enough of, this is what you would end up with. And then the nice thing is this 2x cancels with this negative 2x, and this negative 5 cancels with this positive 5, which becomes positive. And we are left with the limit as h approaches 0 of just this 2h up top all over h times square root 2x plus 2h minus 5 plus square root of 2x minus 5. And then we're happy because the h's cancel. And once that h cancels, remember, that was the problem. We can now direct substitute in 0 for the remaining h's. We end up with 2 all over. There's 2 of these square root of 2x minus 5s, so it's 2 root 2x minus 5. Because if we're adding them up, there's 1 plus 1, it's 2 of them. 2 times root 2x minus 5, which then simplifies to 1 all over the square root of 2x minus 5. So there's the derivative of that function as a function. And then I could plug in any number I want, and I could get the derivative at that point. Okay? So that's the definition of the derivative.